In this video, we're revising similarity and congruency. In grade 9, you also started comparing triangles, and we focused on triangles that are similar and triangles that are congruent. For similarity, we use the symbol of 3 vertical lines, and for congruency, we use 3 horizontal lines. Similar triangles have exactly the same shape, but not necessarily the same size. This means that the corresponding angles are the same size and the corresponding sides are in the same proportion. In the sketch below, you can see that all the corresponding angles are the same size. Therefore, these two triangles are similar. And this means that the corresponding sides are in the same proportion. 4 is doubled to 8, and this doubling is also true from 3 to 6, and from 4.5 to 9. Congruent triangles have the same shape and size, and are therefore identical. Of the 6 corresponding sides and angles that there are in 2 triangles, a specific combination of only 3 of these are necessary for us to be able to accept that the triangles are congruent. So the first of these minimum requirements is the 3 pairs of corresponding sides. Or it can be 2 pairs of angles and only 1 pair of sides, or 2 pairs of sides and then, very importantly, the included angle, or lastly it can be a right angle with a pair of hypotenuses and another pair of sides. Let's go and have a look at some examples of congruency and similarity. Example 1. In the sketch, EF is parallel to GH. So now you need to immediately remember that you might be able to use alternate, corresponding, or co-interior angles. Then we are also given that ED is the same length as DH. The first question to prove triangle DEF congruent to triangle DHG. For this, we need to identify which of our minimum requirements we have here. We've already mentioned that ED is the same length as DH, which means we have a pair of sides. Next up, you will need to make use of previous geometry knowledge. You need to see that you can make use of alternate angles to say that angle F is the same size as angle G, and now we also have a pair of angles. For the third requirement, you now have more than one option. You can either use alternate angles again to say that angle E is the same size as angle H, and then we have another pair of angles. Or you can have vertically opposite angles and say that angle D1 is the same as angle D2 for another pair of angles. Now we can go and write down all our measurements that are equal. In triangle DEF and triangle DHG, we know that ED is the same length as DH, and that was given to us. For the first pair of angles, I'm going to choose to use angle F, and that is equal to angle G because of alternate angles with our parallel lines EF being parallel to GH. For the final pair of angles, I'm going to say angle D1 is equal to angle D2. And the geometry reason for that, they are vertically opposite angles. And now we can make the conclusion that triangle DEF is congruent to triangle DGH. But here, the corresponding angles need to be in the same position. So I wrote D first, which is also equal to angle D in the bottom triangle. E goes with H, and finally F is equal to G. And here my reason is side, angle, angle. Example 2. Triangle ABC is similar to triangle DEF. Determine the values of x and y. In this case, we are given that the two triangles are similar. In similar triangles, we know the corresponding sides are in the same proportion, and those corresponding sides can be derived from the order in which the similarity is given. Side AB and DE will have the same ratio as side BC and EF, and also the same ratio as side AC and DF. So even though sometimes it might be tricky to determine which sides fit together from the sketch, we can use our similarity. We just said that side AB fits with DE. Next, BC fits with FE or EF. And finally, AC goes with FD. And now we can substitute all the information given. AB is 11 centimeters and DE 33. This completed simplified ratio of a third means that triangle DEF is 3 times the size of triangle ABC. BC was given as 6 centimeters and EF is the y value we need to determine. AC is the x value and DF is 24. To solve x and y, I'm going to set up 2 equations by making use of the simplified ratio of a third. So first off, I know that the ratio of 6 over y should be the same as a third. To simplify the algebra, I'm now going to get the reciprocal on both sides and say that y over 6 is equal to 3 over 1. Therefore, we know that y will be equal to 3 times 6, and that means it is 18 centimeters. Similarly, to solve x, I'm going to set up another equation. So x over 24 should also be the same ratio of a third. Again, to solve x, I'm going to multiply, and this time it will be a third multiplied by 24. That is similar to saying 24 divided by 3, which means that x is 8 centimeters.